In this video, we're going to solve radical equations. To solve a radical equation, we're going to follow these steps. Step 1, we want to be sure to isolate one radical on one side of the equation. In step 2, we're going to raise each side of the equation to a power equal to the index of the radical and then simplify. So if we're dealing with square roots, then we're going to use powers of 2 because square roots and powers of 2 are opposite operations. In step 3, if the equation still contains a radical term, that simply means we'll have to raise to a power a second time. In step 4, we're going to check all proposed solutions in the original equation because it is possible that we'll end up with some extraneous solutions. For example 1, we have the square root of 2x minus 3 equals 9. So we can see that the square root symbol appears on only one side of the equation. So to eliminate the square root, we need to raise each side of the equation to the power of 2. So I'm keeping my 2x minus 3 under the square root, but I'll raise it to power of 2. And that means 9 will also need to be raised to the power of 2. Remember that if you have a square root and you raise it to the power of 2, those operations undo each other because they're opposite operations. And so you're really clearing 2x minus 3 from the radical. On the right-hand side, 9 times 9 would make 81. So make sure you are squaring, not multiplying by 2. So 9 times 9 gives us 81. Now notice the result. 2x minus 3 equals 81. This is a linear equation in one variable, so we should be able to solve for x using our properties of equality. So I will add 3 to both sides of this equation to get 2x now equals 84. Dividing by 2, that gives us an x value of 42. Now let's hope that 42 works when we substitute it back into the original equation. That's how we check the answer. So we're going to now have the square root of 2 times our x value of 42 minus 3. And we'll check to see if indeed that equals 9. So that gives us square root of 84 minus 3 equal to 9. 84 minus 3 would be the square root of 81 equals 9. And sure enough, 9 equals 9. So that means we get to keep this answer. X does equal 42. For example 2, we have the square root of negative 10x minus 1 added to 3x equals 0. Well, at first you might think, oh, how nice, it equals 0. Well, that's not standard form for this type of problem. For us, we need the square root isolated. So this plus 3x needs to be eliminated. So subtraction of 3x on each side of the equation will eliminate it. We now have square root of negative 10x minus 1 is equal to negative 3x. In order to eliminate the square root, we're going to square both sides of the equation. So this is the pattern that we're looking for, squaring both sides. So one quantity is the square root negative 10x minus 1, and the other quantity is minus 3x. So on the left side, the square root and the squaring, remember, are opposite operations, so we're really just able to clear all of the terms from that radical. And on the right-hand side, since the negative is inside of the parenthesis, it is a quantity of negative 3 times negative 3, that's positive 9, and then x times x, that would be x squared. So do you notice how this time we ended up with a term that is quadratic? So it's not going to be really quick and linear and solve for x. We have to do some factoring. So that means I need to collect all of my terms on one side of the equation and set it equal to 0. So I think I will leave 9x squared where it is because it is a positive 9. I like a positive coefficient. So that means I'm going to add 10x to both sides, and I'm going to add 1 to both sides of the equation. If I do that, then I can eliminate the 10x and eliminate that constant term. We now have 0 equals our quadratic equation. Now let's be sure to write these terms in the proper order, from the highest degree down to the lowest degree. So now we have 9x squared plus 10x plus 1 on the right-hand side of the equation. So now it looks like we'll have to use our sum and product table to factor. From the middle, positive 10 is our sum, and 9 times 1 makes a product of 9. So either I have 3 times 3 to work with or 1 times 9. So we don't really have a lot of options with product of 9. However, 3 plus 3 gives us a sum of 6. So that doesn't look hopeful. But 1 plus 9, that makes 10. So 1 and 9 are the factors that we want to replace the middle term with. So we now have 0 equals 9x squared plus x plus 9x plus 1. And we've got our 4 terms for grouping. 0 now equals, let's see, a common factor of x multiplied by 9x plus 1. So that means the other factor should be a quantity of 9x plus 1. So remember, what do we have to multiply 9x by to match this first term? That would be positive 1. Is 1 times 1 a match for the last term? So the way this factors is a common factor of quantity 9x plus 1, and our other factor is x plus 1. In order to solve this, we're going to set each of these factors equal to 0. That means 9x plus 1 is set to 0, and x plus 1 is set equal to 0. It looks like we'll subtract 1 to get 9x equals negative 1. Division of 9 gives us an x value of negative 1/9. So that is a possible answer. For the other, we'll subtract 1 to get x equals negative 1. So we might have 2 solutions. Maybe only one of these will work. Maybe neither one will work. So we do need to perform the check. Going back to the original problem, square root of negative 10 multiplied by negative 1 minus 1 under the radical plus 3 times negative 1. So I'm checking negative 1 first. And let's see, this is going to give us under the radical, negative times negative would be positive 10 take away 1. And then 3 times negative 1 would be minus 3. And we're checking to see if that really equals 0. Square root of 10 minus 1 means the square root of 9 minus 3. So that's 3 minus 3 equals 0. That's true. So it looks like we're going to be able to keep this answer of negative 1. All right, now the other one is going to be a little more complicated to check. All right, we're up for the challenge here. Square root of negative 10 is multiplied by negative 1/9, and then we are subtracting 1. Outside of that radical says to add 3 times negative 1/9. And we're checking to see if that is equal to 0. All right, multiplying negative 10 times negative 1/9, you might want to think of negative 10 as negative 10 over 1. Negative times negative makes a positive number. So under the radical so far, we would have 10/9 minus 1. Now, how could we rewrite minus 1 so that it's written with ninths? How many ninths are the same thing as 1? Well, that would be 9/9. So that's what we have under the radical. Now that doesn't look so bad. Outside of the radical, addition of 3 times negative 1/9. So maybe think of that as 3 over 1. So multiplying numerators, we have negative 3. Denominators, we have 9. So we are subtracting 3/9. And then we need to see if it really equals 0. So back under the radical, 10/9 minus 9/9, that would be the square root of 1/9. Then subtract 3/9. See if that equals 0. Now with the square root of 1/9, remember our quotient rule is going to help us to work with that. Square root of 1 over square root of 9. That's the same thing as 1/3. So this first term, square root of 1/9, that is really 1/3. So what we have is 1/3 minus 3/9 equal to 0. Well, I bet we could reduce 3/9. Isn't that the same thing as 1/3? So 1/3 minus 1/3 equals 0. 0 does equal 0. So both of our answers really do work. Okay, both are acceptable. In example 3, we have the square root of 4 minus x is equal to x minus 2. So that looks pretty different from the other problems. But what's the same about it is that we still want to make sure that our square root is isolated, and then we'll raise both sides of the equation to the power of 2. So we already have the radical isolated, so we're going to square both sides of the equation. Remember, square root and squaring are opposite operations, so 4 minus x is released from the radical. However, quantity of x minus 2 means that we have 2 identical quantities. So expand it and then multiply. X times x would be x squared. X times minus 2 is minus 2x. Then distribute. Negative 2 times x is minus 2x. Negative 2 times negative 2 is plus 4. So it looks like I have some like terms to simplify here on the right. 4 minus x is equal to x squared minus 4x plus 4. When we scan, we notice again it's quadratic, so we're going to have to use some factoring to help us solve this. So I want to collect all my terms on the right-hand side of the equation. So that means subtracting 4 from both sides and adding x to both sides. So we eliminate everything on the left side. 0 equals just what we wanted. Starting with our highest power, we've got x squared. In the middle, negative 4 and positive 1 make minus 3x for that middle term. 4 minus 4, well, that's eliminated. So we end up with 0 equals x squared minus 3x. So the factoring needed here is greatest common factor. What's the same about x squared and 3x? Both have x. So the other factor must be x minus 3. We'll set each of these factors equal to 0. So x will be set to 0 and quantity x minus 3 will be set equal to 0. So the first one solved itself. Maybe x can be equal to 0. We'll see if that works in a minute. And here we'll add 3 to both sides. So maybe x could equal 3. Let's check those out. So first we'll have square root of 4 minus 0 equals 0 minus 2. So it looks like square root of 4 equals negative 2. 2 equals negative 2. No, 2 does not equal negative 2. So that answer of 0 is not going to be one of our actual answers. That's what we would call an extraneous solution. Next, we'll check positive 3. So that means we would have square root of 4 minus 3 equal to 3 minus 2. Square root of 1 equal 1. 1 equals 1. That does work. So we will keep our solution of x equals 3. In example 4, we have square root of 3x plus 1 added to 2 equals 0. So we must isolate the radical. We'll do that by subtracting 2. Here we have square root of 3x plus 1 equals negative 2. Next, we'll square both sides of the equation. So we are releasing the terms from the radical. Squaring the quantity of negative 2, we end up with positive 4. This time it's back to being a linear equation, so we like these. They're a little faster to solve. And we end up with 3x now equals 3, divide by 3. So it looks like x might equal 1. Let's check it and see if it works. Don't ever assume your answers are going to work. Always check them. So 3 times 1 added to 1 plus 2, does that equal 0? So this would give us 3 plus 1, or square root of 4, add 2 equals 0. 2 plus 2 equals 0. Does 4 equal 0? No. Now I'll tell you one thing that you'll find helpful. What I want to point out to you is something that will help you in the future with these problems. Do you notice back at the very beginning here, we had a radical equal to a negative number? Let's think about that. If we're taking the square root of something, will it ever end up to be a negative 2? If we ended up with a negative number under the radical, we wouldn't even have a real solution. So there's no way that we're going to be able to find some value of x to equal a negative number. So right from the start, that was a clue. There's not going to be a solution that works. But if you forget that you can't have a radical equal to something negative and you work it all out like we did here, hopefully you'll be able to find that in the end, when you check the answer, that's where you're going to catch that there's no solution. So either you're going to catch it right away, or in the end, you'll find it out when you check your solution. In our final example today, you'll notice that there's a square root on both sides of the equation. So our goal, remember, first of all, was to make sure that the radical is isolated on one side of the equation or on each side. So we do have a radical on each side and no other terms. So we do, again, want to square both sides of the equation. So we're going to have a radical squared equal to another radical squared. So writing down the terms we were given under those radicals, this is what it would look like. So the square root squared simply releases the terms from under the radical. So we would have 2a equals 4 now equals a minus 1. When we scan it, it looks linear. So I'm going to collect all my variables on the left side of the equation by subtracting a from each side. That leaves me a minus 4 equals negative 1. To collect the constant terms on the right side, I would add 4 to both sides. And now a equals 3. So I want to go ahead and check to see if that really works. So when we check the answer, we're going to have the square root of 2 times 3 minus 4. See if that really equals the square root of 3 minus 1. So on the left side, this would be 6 minus 4 equal to square root 2. 6 minus 4 makes square root 2 equals square root 2. Well, that is a true statement. That's what we would call an identity. Those numbers are exactly the same, so of course they must be equal to each other. So that means we get to keep our solution. There really is one solution, and that is a equals 3.